Find the derivative of g of t equals the tangent of square root of t times 2t plus 1 to the 4/3. So g of t here is a trig function tangent of an entire expression which itself is a product of the square root of t times the 2t plus 1 to the 4/3 power. Before I take a derivative, the first thing I'm going to do is rewrite the square root as t to the first power second root, so t to the 1/2, so that we can take the derivative, and then we have the 2t plus 1 to the 4/3 power. So overall we have the tangent of what is a product. We're going to start with the derivative of the tangent, and then we leave the inside alone. We take the derivative of the inside for the chain rule, and the inside's a product, and we'll use the product rule for the derivative of the inside. So the overall derivative, g prime of t, will be the derivative of the outermost function, the tangent. Derivative of tangent is secant squared. You leave its entire inside alone, so t to the 1/2 and 2t plus 1 to the 4/3 power. And now we multiply by the derivative of the inside, which is a product, so we'll make use of the product rule. The derivative of the first, here's the inside right here. It's all of that. And the first is the t to the 1/2. So the derivative of the first will be a power rule. Bring down the 1/2. Subtract 1 from it. I'll call it 2/2. Derivative of the first times the second left alone plus the first left alone, t to the 1/2, times the derivative of the second. That's a power rule. Bring down the 4/3. We'll leave the inside alone. We'll subtract 1 from the power. That will be 4/3 minus 1, which I will call 3/3. And then multiply by the derivative of the inside to complete the chain rule. So g prime of t is now secant squared of t to the 1/2, I'll just rewrite as square root of t. And that 2t plus 1 to the 4/3, I'll just rewrite as the same thing, 2t plus 1 to the 4/3. And we have this multiplying a 1/2 t to the 1 minus 2, negative 1/2, 2t plus 1 to the 4/3 plus, I'm going to put the constants together. I have a 4/3 and I have an 8. Those multiply to be 8/3. I have a t to the 1/2 and I have a 2t plus 1 to the 4 minus 3, 1/3. We're going to want to simplify this. There's going to be some common factors, and we're going to certainly want to factor those out. From the expression inside the square brackets, the secant squared, we're not going to do anything else with. It's just going to come along with the result in the square brackets. So I'll just rewrite that exactly as we see it. Now inside the square brackets, we're going to have common factors. We have constants, we have powers of a t, and we have a powers of 2t plus 1. And each of those can be factored. One option is to take that negative exponent of t, the t to the negative 1/2 in the first term, and move it to the denominator and get a common denominator. We can always make that happen. Another method is to just factor it out. It'll work either way. Since we're going to be factoring the 2t plus 1 to a power anyway, we might as well just factor the t to a power as well instead of getting a common denominator. But we will need to take those constants and put them over a common denominator so we can factor it. I have a 1/2, a 1 over 2, and I have an 8/3, an 8 over a 3. The common denominator will be 2 times 3, or 6. So I'm going to multiply this first fraction, 1/2, by 3 over 3. which will give us 3 over 6. So we have 3 over 6 t to the negative 1/2 times 2t plus 1 to the 4/3. And then the second fraction, 8 over 3, I'm going to multiply by 2 over 2 to give us 16 over 6. And t to the 1/2, 2t plus 1 to the 1/3. The reason we did that is we can now factor out the 1/6. We're not going to be able to factor out the 3 and the 16. They don't have a common divisor, but the 1/6 can factor. And that's a start to the overall factoring. So we have secant squared of square root of t times 2t plus 1 to the 4/3 times. Let's factor a 1/6 out. That'll leave us with a 3. T to the negative 1/2, 2t plus 1 to the 4/3, plus 16, we factor out the 1/6, t to the 1/2, and 2t plus 1 to 1/3. The next thing we can do is start to factor out the powers of t. We have t to the negative 1/2 and t to the positive 1/2. So I'll just rewrite secant squared. We'll just be rewriting that every time. This comes along with the answer. We have a 1/6 that's already factored out. We're going to be able to factor out now a power of t. Now if you look inside here, I have t to the negative 1/2 and t to the positive 1/2. The lower of the two is t to the negative 1/2. Now if I factor out a t to the negative 1/2, I'm dividing, which means I'm subtracting exponents. I'm subtracting a negative 1/2, which means I'm going to add a 1/2. Now if you add a 1/2 to this, that becomes a 0, and t to the 0 is a 1, and that will just disappear. You've fully factored it, which means it will be gone. Now if you subtract a 1/2 from this, it's equivalent to adding a 1/2, and that will become t to a 1/2 plus 1/2, which is a 1, and so that will become t to the 1 after factoring, and that'll be a 1. There's what we're going to have left. It looks like we have 3 times 2t plus 1 to the 4/3 plus 16t to the first power, 1/2 minus a negative 1/2, and then 2t plus 1 to the 1/3 power. Okay, in our next step, we're going to be able to factor out powers of 2t plus 1. So g prime of t equals secant squared of square root of t times 2t plus 1 to the 4/3. We're not going to change that at all. We have this multiplying the 1/6, the t to the negative 1/2, and now to factor out powers of 2t plus 1. Now if we look inside, we have 4/3 power and 1/3 power. The lower is 1/3. So we're going to factor out a 2t plus 1 to the 1/3. That means we're subtracting 1/3 from each of those exponents. When you factor, you're always subtracting. So this will be subtracting a 1/3 here, which will give us 3/3, and 3/3 is a power of 1. And subtracting 1/3 from this other one will give us a 0, and it will get completely removed. So all that's getting taken out, and that's going to become a 1. There's what we will have left inside the square brackets. So it'll be 3 times 2t plus 1, and then plus 16t. So g prime of t here is going to equal to secant squared of the square root of t times 2t plus 1 to the 4/3, all of that left alone. I have 1/6 t to the negative 1/2, 2t plus 1 to the 1/3, and in here I'm going to distribute that 3 in, which will give me a 6t plus a 3, plus that 16t. Okay, now my next step, I'm going to combine like terms in the square brackets. And I'm going to have secant squared square root of t times 2t plus 1 to the 4/3. I have a 1/6. I have a t to the negative 1/2. I have a 2t plus 1 to the 1/3. And combining like terms, 6 plus 16 is 22, so 22t, and then plus 3. So now g prime of t can be written as, now it's customary to put power functions first. So I'm going to put the 22t plus 3 first. Everything's multiplied here, so we can write that first. I have the 2t plus 1 to the 1/3. You might wonder, what about the 1/6? Well, the 1/6 means a 1 in the numerator and the 6 is in the denominator. And so that's what I'm doing. I'm going to be putting the 6 in the denominator. So the 6 is down here. You might also wonder, what about that t to the negative 1/2? Well, it's also going to move to the denominator. It's a negative exponent, so we can move it to the denominator and call it a positive 1/2 power. And the secant squared is going to stay in the numerator, and I'm just writing it last in the numerator just because it's the trig function, and it's also the biggest expression, like so. The only other thing that we can do with this is the 1/3 power means cube root, and the 1/2 power means square root. So we can write this is 22t plus 3 times the cube root of 2t plus 1. The secant squared term will remain as is. And then in the denominator we have that 6, and we have that t to the 1/2, which can be rewritten as the square root of t. And there's our derivative g prime of t.